right, this is lesson 6.3, which is quotient of power property. Quotient of power property. So we're going to be dealing with problems that look like this. And we're going to go ahead and expand this and simplify it to one base and one exponent. Okay? So to expand it, x to the 6th is written as x times x times x 6 times. And then x squared is x times x. Now, if you remember from the launch, things like 6 divided by 6, that equals 1. Because anything divided by itself is 1. For example, 215 divided by 215, that equals 1. So is things like smiley face divided by smiley face. Anything divided by itself is 1. So x divided by x also equals 1. Anything divided by itself is 1. So I'll go ahead and cross those out because those reduce to 1. And we're left with x to the 1, 2, 3, 4th power in the numerator and just a 1 in the denominator. So this is x to the 4th. I want you to try and pay attention. How does that number relate to those two? How does 6 and 2 give you 4? Moving on, a to the 9th. I'll go ahead and expand that. 9 a's divided by a to the 12th. So a times itself 12 times. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, anything divided by itself is 1. So a divided by a is 1. A divided by a is 1. 1, 1, 1, 1, 1, 1, 1. So we're left with just a 1 in the numerator, because remember, there is a coefficient of 1 here. And then a to the 1, 2, 3rd power. How does 9 and 12 give you 3? That's what you're paying attention to. Okay, number 3, this is 4x to the 3rd divided by 2x to the 8th. So I'm going to go ahead and rewrite 4 as its factors, which is 2 times 2, then x to the 3rd. I'll rewrite 2 as its factor, which is just 2, x to the 8th. Anything divided by itself is 1. So also the x's. I'm left with just a 2 in the numerator. In the denominator, I have x to the 1, 2, 3, 4, 5th power. Again, how does this relate to this? So if we go back and take a look, 6 minus 2 is 4. 12 minus 9 is 3. And 8 minus 3 is 5. So what we're doing is we're subtracting the exponents. However, in number 1, notice that the exponent in the top was bigger. And so x to the 4th stayed in the numerator. The exponent in the denominator was bigger. And so the a to the 3rd stayed in the denominator. The x to the 8th was bigger, so the x is going to stay in the denominator. So what we're doing is we're really subtracting these exponents. However, if it's bigger in the denominator, that means that there will still be x's left in the denominator. So that's why x to the 5th is down here. Versus here, x to the 6th was in the numerator, so there were more x's in the numerator, and that's why x to the 4th stayed in the numerator. So looking here, we should get 8 minus 3 is 5. We should get x to the 5th power. And since the exponent is larger in the denominator, it should be in the denominator. Go ahead and expand this, though. To double check, 15 is 3 times 5. Then x to the 8th. Anything divided by itself is 1. So we're left with just a 1 in the numerator, and then 3 x to the 5th. So there you go. Let me go ahead and teach you that algorithm. This is what's called the quotient of powers property. So the quotient of powers, quotient is just a fancy word for fraction. A quotient is a fraction. It's also a fancy word for divide. So for all real numbers x, where m is greater than n. So what this is stating right here is that m is the larger number. So why does that matter? Here it has x to the m. If m is larger, that means the bigger number is in the numerator. So we'll subtract the powers, and since m is larger, it's going to stay in the numerator. Versus this one, where since m is a larger number, and the larger number is in the denominator, we'll still subtract the powers. However, the x will stay in the denominator, and we'll put a 1 in the numerator. Subtract the powers, and it will stay where the larger exponent is. So I'm only going to do these. The answer keys to these three will be on your practice, or on the answer key. I'll expand this, and then I'll use the quotient of powers for this one. X to the 6th, I expand it by writing 6x's divided by 2x's, and then I cross off anything divided by itself. So in the numerator, I have x to the 4th power. In the denominator, I have 1. If I want to use the quotient of powers property, I'm going to go ahead and identify where the larger exponent is, and it's in the numerator. So I'm going to go ahead and subtract the powers and leave it in the numerator. Okay. Taking a look at example 2, this says y to the 5th, I'm going to expand it, y to the 9th, and cross off anything divided by itself. I'm left with nothing in the numerator, so really 1 divided by y to the 1, 2, 3, 4th power. I'm going to do the same problem using the quotient of powers property. So first identify where the exponent's larger, and that's going to be in the denominator. So I'm going to subtract 9 and 5, but put it in the denominator. There will be a 1 left on top. So 1 divided by 9 minus 5, which is 4, y to the 4th power. All right, example number 3, these are different problems. I'm going to solve the first one by expanding and the second one using the quotient of powers. So I'm going to first expand 6 by writing it as its factors, which is 2 times 3, and then x to the 3rd. 10 is 2 times 5, x to the 6th. Anything divided by itself is 1. I'm left with just a 3 in the numerator, a 5 in the denominator, and x to the 3rd power. For this one, I'm going to first write 27 as its factors, and I'm just going to write it as 3 times 9. I don't have to break it down to its prime factorization. Just the first thing that I know. Then 81 as 9 times 9. Now I'm going to take a look at the x's. So the x with the larger power is in the denominator. So I'm going to go ahead and pause, go to the denominator, and subtract the variables. Or subtract the exponents, I'm sorry. Move to the y's. The larger exponent is in the numerator. So the y will be in the numerator, and I'll subtract 6 minus 3. 9 over 9 still reduces to 1, so I'm left to 3y to the third divided by 9x to the third. 3 over 9 still needs to be reduced. 3 is 3 times 1. 9 is 3 times 3. Anything over itself cancels. We're left with 1 y to the third divided by 3 x to the third. Go ahead and do your practice.